Welcome to the 8th lesson in statistics for this CSEC mathematics series. In this lesson, we will learn about standard deviation and how to use it to compare data. The syllabus does not require you to know how to calculate the standard deviation, so this lesson will give you how to interpret the value when given. Standard deviation tells us how far values typically stray from the mean. A higher standard deviation means your data points may vary widely. A lower standard deviation indicates most values are closer to the mean. Remember that high or low depends on the data scale. For instance, a standard deviation of 10 might be huge if your mean is 20, but quite small if your mean is in the hundreds. Let's look at some examples to understand this better. In this household budget example, both families spend an average of $1,000 per month. However, family A has a standard deviation of 50, meaning their expenses vary only slightly each month. In contrast, family B's standard deviation of $300 indicates significant fluctuations, making some months far more expensive or cheaper than others. This variability affects financial planning and risk management, highlighting the importance of understanding data spread. In this example, let us examine the mean monthly rainfall of two cities. Both receive an average of 100 millimeters of rain per month. However, City X experiences only about 5 millimeters of deviation, indicating highly consistent rainfall. In contrast, City Y has a standard deviation of 40 millimeters, suggesting significant variability, meaning some months may be extremely wet while others are quite dry. Although both cities have the same monthly average, their difference in standard deviation affects water management, agricultural planning, and expectations for water availability. Finally, investors often focus on average returns, but ignoring standard deviation can be risky. In this case, both Fund A and Fund B yield an average annual return of 8%. However, Fund B's standard deviation of 10% indicates high volatile returns. Some years may see gains of up to 18%, while others could result in a 2% loss. In contrast, Fund A's smaller standard deviation of 2% suggests a steadier performance. Once again, standard deviation highlights how consistent or unpredictable an investment might be, even when the average return is the same. In summary, standard deviation helps us understand how data points deviate from the mean. A larger standard deviation indicates more dispersion, while a smaller standard deviation means the data is more tightly clustered. Depending on the scenario, this can be interpreted as stability or instability. However, it is important to note that standard deviation measures the variability of the mean, not the actual outcome a data user will experience. Thank you for joining me in this lesson. Remember, you can find this content and additional resources on the website linked in the description. If you have any questions, feel free to ask and I'll be happy to help. See you in the next lesson where we'll discuss how to draw a cumulative frequency curve.